Let's check out, can Google achieve artificial general intelligence by scaling this new model and another jaw-dropping breakthrough towards artificial general intelligence. PaLM-E is a large language model, LLM, developed by Google AI. It is based on the Pathways language model, PaLM, which is a 540 billion parameter LLM. Amazingly, this was accomplished by merging Google's massive PaLM-E language model with the largest vision transformer neural network to date known as BIT22 to create the new PaLM-E multimodal AI model, which has an astounding 562 billion parameters. The secret behind PaLM-E architecture lies in its embedding of continual embodied observations like images, state estimates and other sensor modalities into a pre-trained large language model's embedding space. With the largest PaLM-E model being able to process natural language at the PaLM level while also being able to expertly comprehend and describe image content plus control robots through precise sequential steps by combining language and computer vision. Furthermore, while Google previously demonstrated that language models can assist robots in navigating with PaLM-E training approach, which combines training in different domains, resulted in significantly higher performance than models solely optimized for robotics like its PaLM predecessor. Even more incredibly, the diverse training approach adopted by Google for PaLM-E also has numerous benefits, including enabling the AI model to even transfer its skills from the vision language domains to be used for embodied decision-making tasks, making robot planning tasks more efficient in terms of data usage, with PaLM-E being designed to handle a broad range of visual and robotics tasks as demonstrated by Google through various instances. Impressively, in one such demonstration, PaLM-E controls a robotic arm that arranges blocks using both visual and language inputs to solve the task. In fact, PaLM-E even generates the solution instructions step by step from the visual input, allowing it to sort blocks by color and move them to different corners. Shockingly, the multimodal AI model can also generalize, as seen in a video where it guides the robot arm to move red blocks towards a coffee cup precisely and as instructed. Despite there being only 3 examples of coffee cups in the training data, none of which had red blocks included in the image. Additionally, PaLM-E is a proficient vision language model capable of recognizing individuals like basketball star Kobe Bryant in an image and then generating textual information about him, such as the number of championships he's won. The model can even identify traffic signs and explain their associated rules. Most excitingly, the smaller models of PaLM-E suffer a significant performance decrease in language skills as a result of their multimodal and robotic training, which is an issue known as catastrophic forgetting and is typically avoided by halting language model training during other forms of training. Moreover, what's almost creepy is that the largest PaLM-E model with 562 billion parameters is already displaying emergent abilities like multimodal reasoning chains and the capacity to reason across several images, despite being trained solely on single image prompts. This means that in addition to being trained on robotics tasks, Google's PaLM-E is also a visual language journalist with state-of-the-art performance. Visual question answering plus it retains journalist language capabilities with increasing scale, meaning that by scaling alone, it will become more and more generally intelligent. But that's not the only leap forward in general AI, as another breakthrough called Mimic Play from NVIDIA and Stanford has also just been revealed to possess the ability to generalize when mimicking humans to complete robotics tasks. Just by watching Mimic Play is a scalable imitation learning algorithm that utilizes 2 types of data sources: low-cost human play data and small-scale teleoperated robot demonstration data. The algorithm has a hierarchical design that involves 2 stages. Amazingly, compared to prior methods, Mimic Play achieves a performance improvement of over 50% in 14 challenging long-horizon manipulation tasks. And the algorithm's success suggests that future research in robot imitation learning can realize a dramatic benefit by using this affordable human play data. The paradigm here is that imitation learning from human demonstrations lets humans teach robots manipulation skills in the real world without having to tediously program the robots themselves for each task. However, learning complex long-horizon tasks by just watching often requires an impractical amount of demonstrations to overcome this challenge. The AI researchers turn to human play data, which includes video sequences of people interacting with the environment using their hands. The researchers hypothesize that despite differences in morphologic, human play data contains valuable information about physical interactions that can facilitate robot policy learning. To test this hypothesis, they introduced their hierarchical learning framework called Mimic Play to learn latent plans from human play data and guide low-level visuomotor control trained on a small number of teleoperated demonstrations. Their evaluations of 14 different long-horizon manipulation tests in the real world show that Mimic Play significantly outperforms state-of-the-art imitation learning methods in task success rate, generalization ability, and robustness to disturbances. Plus, it can learn from just a small amount of multitask teleoperated robot demonstrations. The Mimic Play framework is designed to tackle long-horizon manipulation tasks and has two stages. In Stage 1, a goal condition, high-level controller learns latent plans from human play data by predicting future 3D human hand trajectories. According to the goal image. In Stage 2, the pre-trained planner generates latent plans based on the goal image sampled from the task video prompt. The robot policy is then trained using a plan-guided imitation learning algorithm. This two-stage approach is more efficient in terms of samples and has a higher success rate for long-horizon tasks compared to previous works. Moreover, after just 10 minutes of training, Mimic Play can generalize to new tasks with unseen temporal compositions. But that's not all, because another new text-to-image artificial intelligence model called Composer has been released by Alibaba and Ant Group in China, which has been developed for creative and controllable image synthesis with compose conditions. This greatly expands the control space through composition, providing countless ways to generate and manipulate images with much greater control than other texted image methods. Although large-scale generative models trained on big data can produce stunning images, they lack controllability. This work introduces a new generation paradigm that enables flexible control of the output image, including spatial layout and palette, without sacrificing synthesis quality or model creativity. The Composer approach decomposes images into representative factors, which are then used as conditions to train a diffusion model. During inference, the rich intermediate representations serve as compose elements, creating a vast design space for customizable content creation. All of this allows for region-specific editing, color interpolations, image reconfigurations, image variations, composition of intensity and palette, composition of text and palette, and much more. But texted image generation aside, with all of the rapid advances in artificial intelligence, with the ability to generalize, it appears as though the advent of AI may be much closer than many people realize. Thanks for watching.